Let's continue reviewing structure and reactivity. These three pictures show different ways to represent molecules. Structure is how atoms bond together. Stop the video and answer these two questions. Question 1, the answer is covalent bonds. For question 2, let's take a look at structure. So we have two CH3 groups bonded to a carbon, which is bonded to an H. That carbon is bonded to two hydrogens, this carbon is bonded to an H. That's bonded to another H, which is bonded to a CH3. Note that this carbon has only 3 bonds as this one, so this must be a double bond. Therefore, this structure must be B. Let's review shape and isomers. So stop the video and answer these two questions. For question 3, the answer is tetrahedral, each single bonded carbon, and trigonal planar for the double bonded carbons. And for question 4, the answer is B and C. Note that B and C have the same chemical formula but different bonding. Bonding tells us about reactivity. Consider the carbon-oxygen bond. Stop the video and answer these two questions. So electronegativity helps us answer these two questions. Oxygen is more electronegative, therefore oxygen has the partial negative charge, carbon has the partial positive charge, which means that oxygen will be the nucleophilic atom. Structure and shape tell us about reactivity. Remember that most organic reactions are polar, they're reversible, and there are only a few reaction types: acid-base substitution, elimination, and addition. And if we can identify those structural features, we can determine how a reaction occurs. The structural features include the leaving group, which is a weak base for a good leaving group, the alpha carbon, the beta carbon. You also look at vinylic carbons and the allylic carbon. Structural features determine the reaction type, so stop the video and determine the structural features in the compound below and the reaction type. This compound has 2 leaving groups, a good one and a poor one. It has an alpha carbon here and there, beta carbons, which have H's bonded to it, and also a pi bond. So based on this information, note that there can be a substitution reaction, elimination reaction, and addition reactions. This table matches the structural features to a functional group, so stop the video and fill in the blanks. Okay, here are the answers. The reaction conditions determines how reactants form products, so stop the video and fill in all those blanks. So here are the answers. Ozonolysis, a carbon-carbon double bond is converted to a carbon-oxygen double bond. Hydroboration, an alkene undergoes hydration in a non-Markovnikov addition. NBS, that specialized brominating agent. Note that it's going to react at the allylic carbon. Light in Br2 is the radical bromination reaction, that's a substitution reaction. NaNH2 is used to make the acetylide ion. Br2 is the alkene bromination reaction, and KOH is a strong base. That's used for many reactions. Many organic reactions are reversible, so stop the video and look at the second reaction. Which one is the addition? Which direction is the elimination? So there's your answer for question 2. Using curved arrows to show bonds breaking and forming is an important skill which helps us predict how a reaction occurs to form products. So stop the video and use those curved arrows to show how each reaction occurs. In the first reaction, the base is the nucleophile, so we start the air at the nucleophile and at the electrophile. In the second reaction, the pi bond is the nucleophile, the H and the HBr, which is an acid, is the electrophile. So that's going to form this intermediate. And then the Br minus is going to react at the carbocation, and that'll form our product. So predict the products of these two reactions. For a hint, identify the nucleophile and electrophile and use curved arrows. In the first reaction, the O is the nucleophile, E is the electrophile. That'll form this product here. And in the second reaction, the nucleophile reacts at the acidic proton, and that'll form the other product. Practice these 4 reactions. So stop the video and draw the product of the reaction. Again, identify the nucleophile and electrophile. Use those curved arrows to help you out. So here are my answers. In this first reaction, note that there's no reaction. There's no nucleophiles in this structure here. In the second reaction, note that the Cl behaves like a leaving group, so it could be the substitution product or the elimination product. In the third reaction, the pi bond is nucleophile, so here is our product. And in the fourth reaction, a nucleophile can't react with nucleophile, so no reaction occurs. So predict the product of this reaction. Again, identify the nucleophile and electrophile and use curved arrows. So note that the Br is a leaving group, the ethoxide ion is a nucleophile, so this is either going to be a substitution reaction or elimination reaction. So answer these 4 questions. Again, identify the structural features and use those curved arrows. So I've shown the structural features on this molecule and circled the answers.